Hermition matrix is we already discuss about the transpose of matrices. Then Hermition matrices of A matrix is denoted by Aij of M cross N. Then A is said to be Hermition matrix if A equal to AH. What is AH? This is equal to A transpose conjugate matrix. We take example of Hermitian matrix. If we take example of Hermitian matrices, we will choose a matrix 1, 2, 1 plus iota, 1 minus iota. Then if we firstly we conjugate it, that is A. Now A bar equal to 1, 2, 1 minus iota, 1 plus iota. Now A bar का transpose. What is A bar transpose is 1, 1 plus iota, 1 minus iota, 2. It's equal to A. So clearly we can say that A is a Hermitian matrix. A is a Hermitian matrix. Okay. Now we come to our next point. Is the other type is idempotent matrix. Idempotent matrix. What is idempotent matrix? A matrix is said to be idempotent if A square equal to A. The simplest example is its identity matrix 1001. What is square? I square is 1001 into 1001. That is equal to 1, 1 equal to I. So we clearly say that it's a idempotent matrix. Another example is zero matrix. If we take A equal to 0, 0, 0, 0, then A square also equal to 0, 0, 0, 0, 0, 0. So then A is also a idempotent matrix. The another example is we can take 3 minus 6 1 minus 2A. Now we find A square. A square is 3 minus 6 1 minus 2 into 3 minus 6 1 minus 2. When we square this, we can find out that A 3 minus 6 1 minus 2 equal to A. Now we come to our another properties of these matrices. Let A is a idempotent matrix. A is idempotent. Then A square is idempotent. A square is idempotent. A transpose is idempotent. Okay. And A is idempotent and I is identity matrix. Let A है. A is a idempotent and I is identity matrix. Then I minus A is idempotent. We prove this. I minus A equal to I minus A का square equal to I minus A into I minus A. This is I minus A square. I minus A square minus A plus A. This equal to I minus A square. For I minus A square equal to A. A is idempotent matrix. This equal to I minus A. So clearly this equal to I minus A. So this is a idempotent matrix. Okay. The next thing is let A be A is a idempotent and B also idempotent and AB equal to BA equal to 0. It's given that AB equal to BA equal to 0. AB equal to BA equal to 0. Then A plus B also idempotent. We prove that we prove previous that A plus B का whole square equal to A square plus B square plus AB plus BA. That will be equal to A square plus B square plus 0 plus 0. This is equal to a square plus b square. Here we see that 0 is a 0 matrix. Okay, the next thing is if AB equal to BA and if AB equal to BA, then AB also a idempotent. We see there AB square equal to AB into AB, AB equal to BA. So that is we write that AB, A, BB, and A and B are idempotent matrix. Then A square, B square is equal to A, B. Kadam. Now next thing is nilpotent matrix. Let A is a matrix such that A की power matrix of order n and A की power k equal to 0. For then we say that A is nilpotent matrix. Now properties. K is a least number such that k A की power k equal to 0. So what is this implies that A की power k equal to 0? K is index and the 1 less than equal to k less than equal to n. The range of k is this. Now we conclude some properties. First property is if A की power if A की power k equal to 0, then C into A की power then C into A is also nilpotent. For every C belongs to R, or for all we can say that for any field we can see that C की power A की power k equal to C की power k A की power k, this equal to 0, C की power k equal to 0, but converse not true. If we take A equal to 1001, okay, then C equal to 0, then C into A equal to 0. It does not imply that A is nilpotent because A is identity matrix in idempotent matrix. Okay, now we come to our next topic is involutory matrices. Involutory. A matrix is said to be involutory matrix if satisfy the property A square बराबर I. Okay. Mm, simplest example is identity matrix. Identity is equal to I. The second example is 0 minus iota 0 equal to when we do A square बराबर identity. So then we can see that it's a involutory matrices. Now we come to another point, that is uh, normal matrices. If that is normal matrices, if matrix is said to be normal, firstly we tell ID normal matrices. Let A is a matrix square matrix. Sorry. Then A is normal if A into A theta equal to A theta into A equal to identity. Then it's said to be a normal matrix. Okay. Hmm. तो एग्जाम्पल इसके एग्जाम्पल है इसकी सिमेट्रिक मैट्रिसेस because in exclusive metric A into A theta equal to uh, A into A theta equal to minus का A square is equal to, sorry, A does not get, that is the property, sorry. A normal matrix is A into A theta equal to I into this only, only this. So this will be equal to minus A theta into A. So it's a normal matrices. Now we left with the determinant, rank, and we I see some matrices. Huh. Uh, One point, it's inverse matrix, invertible matrices. A matrix is said to be invertible if A is invertible if, firstly condition, H is square matrix. Second, there exists a matrix B such that AB equal to identity. Then A is said to be invertible and B is denoted as A inverse. We have two methods to find this matrices inverse. So we will